Okay, the last couple of examples we're going to look at are some application problems, so some word problems. So example 4 says, how long does it take for a $100 investment to double in value in an account that pays 6% per annum compounded monthly? So let's think back to the formula for compound interest, since we are looking at compound interest in this case. It's compounded monthly. And so the formula was A equals P times 1 plus I to the exponent n. And P was the principal amount, so the amount that's invested originally. A is the accumulated amount, so the amount of money that you have at the end. I was the interest rate per compounding period, and so that would change if you compound interest more regularly. And n is the number of compounding periods that we're looking at. Okay, so what we're asked to figure out is how long it takes, so we're looking at a time, for a $100 investment to double in value. So what that tells me is that the principal amount that we're investing is 100. And so if you're looking at double that amount, then the accumulated amount would be 200. If we're looking at the interest rate would be 6% as a decimal, so 0.006, divided by the number of compounding periods. So remember, I represents the interest rate per compounding period. And because interest is being compounded 12 times a year, when it's monthly, you know that the interest rate per compounding period would be 0.005. And then the number of compounding periods are 12 times a year, and so we don't know how many years the investment has happened for. And what we're trying to solve for is T, which is the number of years of the investment. Okay, so let's plug in all the information we know. So we have 200 equals 100 times 1 plus I, so 1.005 to the exponent 12t. So 12 times a year for t years. And so we're just solving an exponential equation here, so we're going to take both sides and try to get the exponential part by itself so that we can solve for the exponent part. And so I'll get rid of the coefficient of the exponential part first by dividing both sides by 100. And so what I'm left with is 2 equals 1.005 to the exponent 12t. And from here, because I have a single term on both sides of the equation, I can actually find the log of both sides. And then because I took the log of both sides, I can apply the power law of logarithms to bring down the exponent part. And then if I want to get the variable t by itself, I can divide both sides by 12 times the log of 1.005. And I get t is approximately equal to, since I'm looking for a time value, I can solve for an approximate answer instead of leaving it as an exact answer. So the log of 2 divided by brackets 12 times 1.005 log, and I get an answer of about 11.6. Okay, so that's how long it takes roughly in years to solve, to double the investment. So therefore, it takes about 11.6 years for the investment to double in value. Okay, there you go. Okay, so remember whenever you're doing your division here, so just as a side note, remember to put brackets around the 12 times the log of 1.005 to ensure that your solution is correct. Okay, so don't forget to do that. Okay, let's take a look at the next example. So example 5 says the number of ants in an anthill doubles every month. If there are now 600 ants, about how long will it take for the population, or their population, to grow to 9,600? So what we know in this case is that it's doubling, the population is doubling every month, and we know the initial amount of ants, and we want to know how long it takes for it to be 9,600. So let's start by looking at the base formula of an exponential function. And that's y equals a times b to the exponent x. Y is the dependent variable. A is the initial value. V is the growth or decay ratio, and X is the number of growth or decay periods. So what I know is that I want to know how long it takes for the population, so I'll rewrite this equation using population. I want to know how long it takes for the population to double in value. And so I know that the final population is 9,600. I know the initial population is 600. I know it's doubling every month. And so I'm looking for the time. Okay? And the fact that it tells me it doubles every month tells me that it's happening 12 times a year. But it doesn't specify what terms that you want for your time value, so I can leave it as just t. So I'm going to solve this just like I did the previous question by dividing both sides by 600 first. And I get 16 equals 2 to the exponent t. And luckily in this case, I can write 16 with the base of 2, so I get 2 to the exponent 4 equals 2 to the exponent t. And then because the bases are the same, therefore 4 is equal to t. And remember that t looks at the number of months, so therefore, I ran out of lead, the pen. So therefore it will take about 4 months for the population to grow to 9,600. Okay, and there you have it. So here's your assigned work. It's from your textbook. So on pages 374 to 376. And then you're working on that in class tomorrow. And then don't forget to watch the video for lesson 3.